Our next contestant is Meagan Kelso, PhD student in Materials Science and Engineering. Her presentation is on silicone 643 as a versatile chiral template.
Remember the last time you went to the doctor or the pharmacy for your headache, your back pain, chest pain? The doctor prescribes you a medicine, or you pick it up over the counter. You take it, and within a short time, the issue is resolved. But then come the side effects, like nausea, drowsiness, irritability, or worse. In many cases, this is due to chirality. Chirality is just like your right and your left hand. Two molecules have exactly the same chemical composition, like you have the same 5 fingers on each hand, but they're arranged differently. The molecules, like your hands, are mirror images of each other, and they're not superimposable. So if you put one on top of the other, no matter how much you rotate them, they'll never line up. This property, non-superimposable mirror images, is called chirality, and more than half of the common medicines we take have this property. Just like a key, one hand of a molecule is arranged just right to resolve your headache, while the other may do nothing or may cause those harmful side effects. This was the case when they first discovered how much chirality really mattered in medicine, when they gave a mix of this R and S, or left and right hand thalidomide, to pregnant women to treat their morning sickness. Unfortunately, only one hand was effective as the medicine, while the other caused some pretty serious birth defects in thousands of children. So the question is, how can we separate each hand from each other? Current techniques are expensive and time-consuming, so that many medicines are actually left in their mixed form. My project focuses on sensing either hand and separating each hand from the other using a 2D chiral silicon surface. Normally, silicon is not chiral, but when we slice it along certain crystallographic planes like this 643 plane, we're left with the atoms arranged in a non-superimposable mirror image kind of way on just the surface. Because silicon is used in so many of our electronics already, all the manufacturing equipment is already set up to obtain our single crystal wafers. Then using a low energy electrode deposition process, we can grow a nanometer thick, smooth film of gold on top of silicon, which can sense or separate each hand from the other. Because different molecules respond better or are more active on different materials, we can also tune our chiral surface by growing other metals or metal oxides, which will work best for each molecule. With our earth-abundant silicon and low-energy processing methods, we can not only hopefully improve upon current techniques, but also greatly reduce the cost, so that more medicines are given in only their effective form and more side effects are avoided. Thank you.